Sir, you can start, sir.
Thank you. So, the major components of a transmission system in a tower, we were discussing about the important components being the insulators, which are very important for a transmission system. After the insulators, the conductor is equally important. Then we have hardware fittings or accessories, then the tower and its foundation. So, we have discussed about the insulators which are used for the EHV and UHV transmission. We will now look into the conductors, that is the various type of conductors, the importance of conductors, and earth wire or the ground wire which is being connected to the high voltage tower. Further we will be focusing on the hardware fittings. Hardware fittings generally comprise of the metal parts which are connected to the tower, to the insulator. So, these are yoke plates or corona control rings. Then we have vibration dampers which are used for the reduction of the vibrations caused due to wind and other sources. We have other accessories like the clamps, connectors, and many of these which we will be discussing about that aspects. Further we will discuss about the various types of towers and the foundation requirements for the EHV and UHV transmission system. So, conductors for transmission system are very important. These are the conductors used for high voltage transmission connected to the insulator string. So, conductor is basically material that allows electric current to pass through it. It is a basic definition. So, types of metals such as silver, copper are usually the best conductors which are used for the electricity at the domestic and also for the transmission and distribution systems. This is a typical conductor which is used for the domestic lighting purpose, and we will be focusing on the conductors, various types of conductors which are used for the extra high voltage and ultra high voltage transmission and distribution systems. So, further these are the conductors with the stranded on known as the stranded conductors. The stranded conductors, the importance of that, why stranded is required, we will look into that. So, various types of conductors depending upon the voltage level and the current it has to carry. So, depend upon that the usage of conductors are being employed. So, we know that significant changes have occurred in the electrical utility industry. So, it was to be noted that significant changes have occurred in electrical utility industry since Thomas Alva Edison began commercial sale of electricity more than 100 to 120 years ago. The area, one of the area that has undergone extensive changes, rapid changes have been in the types of conductors, particularly for the transmission and distribution of electricity. So, initially copper was the first material used to transmit electricity, particularly during development of electrical industry in the early 1880s. So, late 1880s the copper was a material which was being used. Later on a revival of selection criteria, particularly for transmission and distribution conductors to prior to extensive of aluminum, suggest that copper conductor sizes were determined on basis of mechanical consideration due to high conductivity of copper and relative to its strength to weight ratio. So, that is the important point to be noted here. So, therefore, the conductors which were required from the standpoint of efficient electrical conductivity is because of its weight, the span lengths, the tower to tower distance in case if it is short, thus increasing the overall cost of a transmission in case of copper. So, shortly before the turn of the century, conductor manufacturers and the utilities planned and started using to replace the copper with the metal that is aluminum, which is a metal of choice for transmission and distribution industry. So, the first transmission line using aluminum conductors was constructed in California in the year 1895. So, later on quickly followed by many further to 1890s, we had a few more lines which were commissioned with the help of aluminum conductors. So, the first transmission line using 7 strand, that is a 7 conductor strand aluminum cable was used by the Connecticut Electric Light Company in 1899. This remained in operation for almost 50 years. So, more than 90 years aluminum has been preferred and has been used by the electrical utilities both for transmission and distribution of electric power by replacing copper for overhead applications. So, aluminum ranks second only to copper, particularly in volume conductivity, and possesses a conductivity to weight ratio twice that of copper, and strength to weight ratio is 30% greater than copper. So, these are the strengths of the aluminum in comparison to the copper. So, in 1907 a new aluminum steel reinforced composite cable, that is a conductor, was introduced. This conductor combined lightweight. So, in 1907 a new aluminum steel composite cable or conductor was introduced. This conductor combined both the light weight and also it was able to carry high current of aluminum with high strength of galvanized steel core. So, this was the introduction in 1907 which is known as aluminum conductor steel reinforced as aluminum conductor, and steel reinforcement became known, which gained rapid acceptance and was used particularly for almost throughout the world until 1939. So, with the excellent conductivity of aluminum conductor steel reinforcement which is having, coupled with excellent strength to weight ratio, ease of handling, made the conductor, that is ACSR conductor, for electrification in many parts of the world, and it was being used in many parts of the world. However, more recently many innovative conductor designs have been also developed, particularly for the extra high voltage and ultra high voltage transmission, which we will be focusing on these aspects, the changes in the design, the changes in the material aspect, and various types of strands which are being used, and the dimensions of the conductors which are being used for the EHV and UHV transmission systems. So, various kinds of or types of conductors are in use over a period of time. So, we can say that there is no unique process by which all transmission or distribution lines are designed. However, the major cost component of line design depends upon the conductor and its electrical and mechanical parameters. So, any conductor, the major component in a line design depends on electrical and mechanical considerations. So, 4 major types of overhead conductors mainly used for the transmission and distribution for medium, low voltage or high voltage system transmission are AAC, that is all aluminum conductors. The second is AAAC, that is all aluminum alloy conductors. Then ACSR is a aluminum conductor steel reinforced with a steel conductor in the middle, and ACAR aluminum conductor aluminum alloy reinforced. So, these are the 4 major types of overhead conductors which are in existence over a period of time. So, with various combinations and modifications, these conductors provide a wide variety of possible in the conductor designs. So, you can see here the various types of conductors from a low voltage or a medium voltage level to the very high or EHV or UHV level. The conductor dimensions with the number of strands with the number of steel reinforcement differ depending upon the transmission voltages and the current the conductor is to carry. So, both for distribution and for the transmission systems. So, various sizes are being manufactured across the globe. In India, the following sizes have been standardized by the Central Electricity Authority for transmission and distribution lines in the country. So, in general, for transmission or lines of 132 kV systems, the conductor, the nomenclature is a panther. Panther is a name of the conductor of particular size which is of aluminum conductor steel reinforcement, has 7 strands of steel in the middle for a mechanical strength of dia 3 mm, and it is surrounded by 30 strands of aluminum of dia 3 mm. So, 7 strands in the middle, similar to this in the middle, it may be here 7 strands surrounded by aluminum conductors of 30 strands of dia 3 mm. This size of the conductor is being used for 132 kV lines. Typically, the overall dimension of the conductor could be 24 to 26 mm dia. For 220 kV transmission lines, zebra is the name of the conductor for that particular size dimension of 28.62 dia conductor is known as a zebra. Aluminum conductor steel reinforcement has 7 strands of steel similar to the panther of dia higher, slightly higher than the previous, that is 3.18 mm, and contains 54 strands of aluminum of dia 3.18. So, the total number of strands for 220 kV conductor which is of zebra make has 54 strands, outer conductors of aluminum and inner is 7 strands of steel. For 400 kV, that is for extra high voltage transmission system, normally a twin moose again twin moose is the name of the conductor. Twin is 2 bundle conductors, 2 conductors of twin type, aluminum conductor steel reinforcement having 7 strands of steel dia with 3.53 mm and 54 strands of aluminum of dia 3.53. So, that overall dia of the line for the moose conductor being 31.77 mm. So, for further EHV further UHV transmission lines, the conductors namely Bursimis, again name of the conductor, or a lapwing or a bull. So, these are the conductors which are being used for ultra high voltage transmission. Typically, the Bursimis dia overall dia of the conductor being 35.05 mm. In case of bull, it is 36 mm dia, lapwing it is 38.2 mm dia conductors are used. So, quad is the 4 bundle conductor, twin is 2 bundle, higher the voltages you have quadruple bundle or 8 bundle which is octo bundle conductors. So, similarly depending upon the voltage level and the current carrying capability, the bundle number of conductors in a bundle are being used. So, these show the some of the tests, preliminary tests which are to be carried out essentially for the all types of conductors. So, DC resistance is normally carried out for all types of conductors. Ultimate tensile strength. So, this is again mechanical withstand capability is carried out for all types of conductors. Then surface condition test is normally preferred to be carried out above 220 kV system or EHV or UHV lines. So, surface conductivity, corona or radio interference voltage measurement, the surface of the conductor is very important, where the discharges should not affect the transmission of the radios or television or any other communication networks. So, care has to be taken, the conductor has to be smooth and it is free from the discharge when energized. So, there is a bundle conductor. What is a bundle conductor? Basically, a bundling of the conductor or is a combination of more than one conductor per phase. So, we have initially discussed two twin conductors or a quadruple conductors or 8 type of conductors. So, this is the combination of more than one conductor per phase. So, when you see here this has a 4 conductors with a suitable spacer. So, this suitable spacer is a quadruple spacer having a 4 conductors in a bundle. Similarly, you see here 8 conductors in a bundle, 8 conductors of same phase, that is very important. So, the spacing between each conductor is 450 millimeters 45 centimeters, which is typically employed in our country. So, the combination of more than one conductor per phase. So, these conductors could be a single conductor or a twin or a triangular type of conductor where 3 conductors are connected in a bundle, or a 4 conductors which is known as a quadruple arrangement where 4 conductors are connected, or in case of 6 or 8 or 12. So, depending upon the number of conductors, the equivalent spacers are used and the formation is made. So, the individual conductor in a bundle is defined as a subconductor. So, these in case there are 4 conductors, each conductor is known as a subconductor in that particular bundle. This is to see that the advantages is to see the conductors perform better in radio interference voltage or radio interference measurement issues. Then corona performance, because of the shielding effect, the corona performance is much better going in for bundle conductors, and more surface area for heat dissipation. That is one of the important properties. As higher the voltages, this becomes advantageous. So, at EHV or extra high voltage and ultra high voltage, corona with its resultant power loss and particularly interference with the communication is excessive if the circuit has only one conductor per phase. So, up to 132 kV typically single conductor is employed. So, above 132 kV, more than 220 kV, either twin for 400 kV 4 conductors or UHV either 4, 6 or 12 conductors are normally used to counter the issues of radio interference corona related problems which could interfere with the communication circuits. So, the high voltage gradient at the conductor, particularly in the extra high voltage range, is reduced considerably by having 2, 3, 4 or more conductors per phase in close proximity compared with the spacing between the conductor bundle. And as mentioned, the conductor bundle, the conductor to conductor spacing in a country is adopted as 450 millimeters, or the distance between any conductors is 450 millimeters. That is the standard which is being adopted in the country. The 3 conductor bundle, if there are 3 conductors in a bundle, usually the has a conductors at the vertices of similar to an equilateral triangle, and 4 conductor bundle has its conductor at the corners as shown here. See 1, 2, 3, 4 like similar to a square arrangement with 450 mm design between 450 mm gap between each conductor, and it happens if it is more than 8 conductor. You can see here this will have a conductor spacing of 450 mm with a octagonal type of spacer mounted to support the 8 conductor bundle. So, the current will not divide exactly between the conductors of the bundle unless there is a transposition of the conductors within the bundle, but this difference is of not of much practical relevance. So, it could be not an important point to be considered. So, how the conductor are selected or the conductor bundles are selected. So, the methodology remains. Initially the preliminary set of conductor bundles of various size of the conductors are identified to start the optimization. So, important parameters like the insulation requirements for a particular voltage level, the limits specified for the corona, the radio interference voltage, the television interference, the audible noise, the electric field, the thermal ratings of the conductor, the line losses because of the operation at that higher voltage levels, and the statutory clearances should be identified before the selections are made. Very important parameters for the choosing of the conductors. So, further detailed analysis of various alternatives in respect to the following should be carried out, so that it would be helpful to select a particular configuration for the transmission or distribution system. So, the basic insulation design and the insulators selection has to be done, the conductor size has to be identified, what is the insulation level which it has to be used. Then the tower configuration analysis, what type of tower configuration is used for this voltage level where the conductor is being adopted. The tower weight and the foundation cost analysis have to be kept in during the estimation of the conductor bundle selection, and important being the capital line cost analysis and the span optimization of the conductors from the tower to tower, the span which is being planned. Then line loss calculations, again this depends on the voltage level where the conductors are being operated. Then economic evaluations. So, economic evaluations are of alternatives, that is PWRR. PWRR is the present worth of a revenue which is recovered to be recovered. Then a comparison of interference performance have to be made, and the cost sensitive analysis. So, these are the important parameters or points to be taken into consideration while going in for the selection of any conductor bundle for suitable voltage levels.